we have started this advanced permission. Now advanced permission, we have seen ACL permissions, advanced ACL permission. Now the next thing we have seen is this, we have started this, the extra zero of umask. This umask, we have a umask for root user is what, 022, but we have extra zero in that umask and it will remain 0 until we change it. So when we see the umask for normal user is 002 or a root user which is 022, whatever, the extra 0 is there which is 0 by default and it does not change until we change it. So whenever we assign permissions numerically, we don't mention that 0. So whenever we try to change the permission, when we try to change permission numerically, we only mention those 3 numbers, like for user owner permission, for group owner permission, and for other user permission. But we don't mention that extra 0. But that extra 0 is also 3 bit of permissions. And those 3 bits means different permissions. Those 3 bits are having a different permissions. For example, if you are having this bit on, that means you are getting value 1, and that 1 means what? The sticky bit. And if you get this bit on, second bit, so you will get the value 2, and that means SGID. And if you enable this third bit, that means you will get the decimal value 4, and that means you will get the permission SUID. Now we have seen yesterday this first permission, that is if you enable 1, that means you enable sticky bit. That means you enable sticky bit. Now sticky bit means what? And what is the use of this sticky bit? So when you give written permission on a directories, suppose you give a write permission on directories to user, so they can add files in that directory and also they can delete files from that directory. That means if I give user 1 permission to write on directory, that means I want that user 1 should able to create files inside the directory, that is write permission. Now write permission means what? It can create and it can also delete. But if I have multiple users creating files inside the same directory, so we have multiple users, user 1, 2, 3, 4, and they all wants to create files inside the directory. So I gave write permission to all those users. Now all those users can add files in that directory. But the problem of write permission is what? They can also delete. Now they can also delete means what? They can delete their own files and also they can delete any other user's file. Whether they don't have a permission to write or do anything on that file itself, but they can delete those files because they are having a permission on directory. So because they are having a write permission on directory, they can do add and delete, and they can add any file and they can delete any file. Any file means any other user's file also. So the problem will come when user 1 adds a file and user 3 deletes the file. So that is a problem. But because users may sometime do these things, delete other users files also, or manipulate their other users, so we don't want them. So if we remove write permission for the user who is doing these things, then that user can also not create the file. So we want them to create, but we don't want them to delete the file for other users. They can delete their own file, but we don't want them to delete other users file. and in that case we enable sticky bit on that directory. So after enabling the sticky bit, what it will do, after enabling the sticky bit, they can add the file inside the directory because they are having a write permission, and they can also delete the files in the directory because they are having a write permission. But with the sticky bit, they cannot delete other users files, they can only delete their own files. So when the sticky bit is enabled, users cannot delete other users files, they can only delete their own files. And that is what sticky bit. Now how we can enable the sticky bit? That is very simple, we have already seen it. We can use it by doing the chmod command, which we use to change the permissions. And so the command for the changing a permission is chmod, and then we mention the permissions, like whatever permission I want to give, like 777, I'm giving all the permission on the directory name. Then you will mention the directory name. Now when you don't mention anything here, it will remain 0. So when you don't mention, when you mention only 777, that means user permission, user owner permission, group owner permission, and other permission. And we don't mention the stating the existing extra 0, that will be 0. So when you don't mention it, it will remain 0. But if you want to enable sticky bit, then you mention 1 there. And this is what a numerical way. Now when you enable this sticky bit and when you check the permission, then you will see in others permission, it will show you the T command. It will show you the T. That means, let me show you that. Like this is the directory where I enable the sticky bit. So when I enable the sticky bit, I will see this T in others permission. If you see, this set of permission is for others. So you will see the T in that other user's permission. And that means symbolically, if you want to assign the sticky bit, then you can do this by chmod, and you can use others plus T. That means you are adding T in others permission. So whatever permission other has, you are adding T into that. So this is what a symbolic way of giving permission, enabling the sticky bit. And this is the numerical way of enabling the sticky bit. Now when you enable the sticky bit, it will do what? Users can create their files, but they cannot delete other users' file. So right now we are having file from root itself and user2 file. Now if user2, this is user2, this is user1. Now this user is user1. If it wants, then it can also create file, because it is having a permission. All the users are having a permission to create file. Now if it try to edit the file for other user, like user2 file, it cannot do. And if it try to delete other users file, it can also not delete, but it can delete its own file. It can delete its own file because its sticky bit is enabled. Now if sticky bit is disabled, and for disabling the sticky bit, we can do what? For removing the sticky bit, for disabling the sticky bit, we use chmod command, and from here we will give purposely 0. Remember, if you don't give 0, if you give only 777 again, then it will remain 1, it will not change. So when you don't mention it, it will remain as it is. So if you want to change it, then you have to mention it as a 0. So when you mention it as a 0, that means you're disabling the bit. And one more way, symbolic way, for that you will do what? You can do it by using O minus T. That means for removing it, you will do what? Just like you added it into others, you can just select minus T from others, and it will remove permission this sticky bit from others, and it will disable the sticky bit. So if I want to remove the sticky bit on the directory, this directory, this is root, so I enable it on this and I want to remove it. So I will use the same command chmod 777, and if it don't mention, it will remain like this. So you will mention 0 purposely, and then you will mention the directory name. It will remove, or you can use O minus T. Both will work, either you use that or you use this. Actually, first time when I run this command, it is removed. First time when I run this command, it is removed. I am just showing you this command also, but it is already removed. Now when I check this permission of the directory, now you can see there is no T. That means sticky bit is removed, and you can see the color is also changed. This color is for the directory when you give write permission to others, then you will see this color, and when you enable the sticky bit on a directory, you will see this color. Now one more thing, you can see sometime capital T. You can see sometime capital T. Now what that means? Sometimes you will see capital.
Hello, Mr. Taki.
So sometime you will see capital T in place of small t. Now when and why you see this? Now that does not means it is something else. Okay, it will still remain this sticky bit. It does not means it is not a sticky bit. It will still remain a sticky bit. It represents something else. So you may see capital T in place of a small t, and it is also sticky bit. Now what is the difference between a small t and capital T? First I will show you this, when you will see small t and when you will see capital T. Okay, now I'm enabling the sticky bit again. and you will see small t. So 1, that means I'm enabling a sticky bit on the directory, and you will see small t. Now you see it is a small t. Now what I will do, I will disable it again. Now I'm going to show you capital T. Now you see it is showing capital T. Now what is the difference between small t and capital T? You can see here when I assign this and when I assign this. Now what is the different? The difference is very simple. You see here when I assign like this, it shows me small t, and that means if you see the permission, all the owner group and others are having all the permissions. Now when I use this permission with enabling the sticky bit, it shows me capital T. Now what is the difference here is that this other user is not having execute permission. Other user is not having execute permission. Now why it is showing capital T? It is very simple. If you see this, when you enable the sticky bit and you check the permission, it is not showing X. If you see there, it is not showing X. All the permissions are like this: read, write, execute. But now it is showing for others is what? Read, write, T. Now it is not showing execute permission. Now why? Because we enable the sticky bit. But how you know that is it execute permission is there or not there? That means when you see this permission of the directory, so how you will understand that this other user is having execute permission or not? Because it is not showing there, and that is why it shows you in small and capital, and that represents very simple. If the other permissions, other users are having execute permission, then it will show you in a small t, and when other users not having execute permission, then it will show capital T. But both are what? Both are sticky bit. They are not different permission. They are same. Only they are representing what? That other users are having execute permission, or other users are not having execute permission. So only the difference is that. And what I did here, if you see, I give other user only 6, and that means what? Read, write, no execute, and that is why it is showing me what? In capital T, because it remove the X from here, so there is no X. It only shows what? RWT, and that is why it shows capital and small t to represent X there. So when you see this small t and capital T, that means what? It is representing the execute permission, the presence of execute permission. Now it do what? It represents
Mr. Taki.
so when you see small t and capital T, that means it represents execute.
Sir,
Yes.
there is a difference I just saw, but I don't get it.
Which
So when
different?
you,
Small t and capital.
okay, yes. So when you
That
need
is
to
I am
enable
explaining. Wait.
the capital,
Yes. Yes, tell me.
yeah, like you change,
So I'm saying sometime you will see capital T in place of small t, and it is also sticky bit. Don't be confused. Don't be confused. And it represent presence of what? Execute permission for other users. Understand? So it represents the presence of execute permission for other users, whether the other users are having execute permission or not having execute permission. And that means what? When you have for others, when you give others users, or we can say when we give other users read, write, execute permission with sticky bit, then we see small t, and when we give other users read, write permission where there is no execute, with sticky bit, then we see capital T. Very simple. I will put it into note. So this is how this sticky bit. Now next is what? SUID. So we have seen this sticky bit. Now the next number is like the second bit if you enable. So you will get the number 2 and you will get what? SGID. Now remember, this sticky bit is only useful on directory. You can assign on the file also. You can give a sticky bit on, you can enable the sticky bit on files, because Linux will not tell you anything, it will not give you error, but no use, it is not any use. Now if you enable 2, that means SGID. Now that SGID means what? It is set group ID. Now this one is also useful on directory. You can still assign on file, but no use. SGID. Now SGID means what? Group ID. We know that every user and group has their own ID from 1000 to 60,000 UIDs and 1000 to 60,000 GIDs. Now this means what? Setting GID. SGID means set GID and number 2, bit number 2. Now assigning this, enabling this SGID is very easy, just like we did it for sticky bit. In place of 1 we can give 2 and we can enable the SGID. Now the important thing is what it will do. What this SGID will do. Now we know that SGID means group ID. So it will do what? It will set group ID owner group ID on directory. That means it will inherit it. It will inherit group ownership of the directory to on all the files and directories inside that particular directory. That means what it will do? It will do inheritance. Now remember I told you that inheritance is not there in Linux. That means when we assign any permission on directory, it will not give that permissions to inside the directory. That means if you have any files and directory inside that directory, those permission will not inherit to that. So it will not inherit it to any file or directory inside that particular directory. Now this will do what? It will inherit the group ownership. That means if we have a okay, let me make a design. I will make a design here. Insert now. So what happened when we enable the bit, the second bit, that is decimal value is 2. Now what it do here? It actually inherited the group ownership of the directory, in that directory it will inherit the ownership of the directory to all the files inside the directory. Now no matter who creates the file, if it is created by user 1, user 2, user 3, user 4, no matter, it will be inherited. The group ownership will be inherited to all the files inside the directory. For example, now you can see here in the design, this is our directory. This directory name is test. Now in that directory, these users can create file user 1, 2, 3. Now what happen when they create files? This will be the owner, this will be the permission for the file, because these are normal users, and these are normal users, that means they have the umask of 002. Now for that 002, they will get the permission what? Read write and read. That means user owner will get read write, group owner will get read write, and others will get read. Now now when they create a file inside the directory, so this will be the permission because of the umask, and by default the owner user will be user 1 because it is created by user 1, and the group owner of the file will also be the primary group of that user, that is also user 1. Same as for user 2 and user 3 also. Now when we do like this, now when we have a permission like this, then by default all the users will not able to change any other user's directory or file. That means user 1 cannot change anything on user 2 file, user 2 cannot change the file of user 3 or 1, and user 3 cannot change the file of user 2 and 1, because they don't have any permission, they are having only read permission on their each other's file. Now if we enable the sticky, if we enable the SGID on this directory, the test directory, then what it will do, it will inherited the group ownership of the directory. Remember, the group ownership of the directory will be inherited to all the file inside the directory, whether you create file or directory. Now if you see here, the directory owner is root, but the group owner of the directory is what? Sales. So when I enable this SGID here in this directory, what it will do here, it will change the group ownership of any file in the directory to the owner of the directory. That means group owner of the directory. Now permissions will be like this. That means any user create the file, that means if user 1 create a file, then the owner of the file will be user 1, but the group owner will be the owner of that that directory. That means the group owner of the directory will be the owner of all the files inside the directory. So whether user 1 create a file, user 2 create a file, always this sales group will be the owner of all those files. Now you will say, what is the benefit of doing like this? So why we do this? Because sometime what happen, we do enable this SGID when we wants to give write permission to any we can say any admin user or any user who wants to who wants to review all the files inside the directory created by any user. And review means what? He wants to have a write permission. So that means suppose there is a directory where I said all the users, that user 1 2 3, they all can create file, they are having a directory to work on, and I said everyone do sign. That means whatever the work you do, you save it into that directory. And there is a user, maybe as it's an administrator or any authority user, and he wants to do what? He wants to review their files created. So what they have done, so we are having a administrator who his job is to review all those files which is created by those users. So what we want, we want that user, that particular user, we want the user to give a write permission on the files created inside that directory. Now if you want to use the normal way, that means you want to assign the permission by SUID, set FSCL command, then you have to do it every time. That means you have to change every file permission by yourself. That means we are having a user 1 2 3 and we are having a user HR, and I want to give HR user permission on all the files inside the test directory. So what I will do, I will keep looking inside the directory, that whenever any new file comes, then suddenly what I will do, I will quickly change the permission. Like, okay, I will remove this sticky bit. Okay, now no sticky bit. Now what I will do here, first, if I want to change the permission in the directory, so I have to keep looking into the directory. That means I have to set a user administrator that every time run the command. It all every time, like whole day, it will run the command like this: ll 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 ll, and then whenever he sees the new file comes, he directly run the command set fscl, then m, then user hr, and then permission read write, and then it will mention the file name, and then after that again it will start looking ll 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 ll, and then whenever it sees new file, it will directly go set fscl and assign the permission, and then it will keep looking it. It is the way, but it is not practical. We can't do this. We can't do this all day. And if suppose suddenly you see 50 files, 60 files, 100 files, then what? It will take a lots of time to change the permission on all those files and give that user, HR user, permission. It can do one more thing. We can do one thing also. If we make HR user member of this group. That means users owner group, users primary group. So we can see that users primary group everywhere get the read write permission. That means whenever user create any file, this group also get what? Read write permission. And if I add the HR user in this group, so it will also get the read write permission automatically. But it is risky because I want to do it for only this directory, but HR will get the permission on everywhere. Wherever the user create a file, it will get the permission, and that we don't want. So again, we can't do that. And the solution is what? This SGID. So what we do here, we make this group separate group, and we make this group owner of the directory, and then what? We enable SGID on that directory. Then what happens? Whenever any user create a file, this group will be the owner group. That means this group will be the owner group, and the group will always get this read write permission because of users umask. This is the default permission. Now what I will do, I will only add the user HR user, which I want to give the review right to edit those files. I will add that user into this group only. So this group and this group is having a permission read write, so that user will also get read write permission automatically, and I don't have to check anytime because it is become automatic, and it is only on this directory, no any other directory, because this group only belongs, it is only the owner group of this directory, and the SGID is only set on this directory. So in simple word, it do what? It will set the owner group ID on the directory, and that means it will inherit group ownership of the directory on all the files and directories inside that particular directory. Very simple. Whatever the group owner of the directory will be owner of owner of all the files inside the directory, whether it is created by any user. Now what is the use of that? It is the use like we do enable this GID when we wants to give write permission to any user who wants to review all the files inside the directory created by any user. And that is the reason we do what? We enable this SGID. But remember one more thing, it will not change permission on existing files. That means if the files are already there, if it is already created, then the permissions will not change, ownership will not change. But after enabling the SGID, it will change the ownership of any new files. So whenever you create, when any other user create new files, then the permission will be like this. But if it is already there, then it will not change. If it is already there, then you have to change it manually, and you know the command, that is chgrp and changing the group ownership. So you have to change it manually if the files are already there, and if it is not there, whenever you create a new file after setting the GID, the ownership will change. Now to create it, to enable it, it is very simple. To enable SGID on directory, remember it is useful on directory. The command is again chmod, whatever the permission you want to give. For example, I am giving read write execute to all. Read write execute to all on a directory. So when I don't mention anything, it will remain 0. But this time I want to enable the SGID. So what I will do, I will mention number 2. Number 1 for sticky bit and number 2 for SGID. And this is what? This is the numerical way. This is a numeric way. So I will enable on this directory, test directory. Now it is already having the files, so it will not change, but the new files will change. Now let's check the owner of the directory first. So the owner user is root, and the owner group is also root. So I will change this, and you know how to change it. chgrp sales to this test directory. Now we know the owner of the directory is root and the group owner is sales. Now we are having some files inside the directory already. So we are having these two files, but this will not change. Any new file will change. So for assigning the GID, chmod 777 I want to give. Now if I don't mention, it will remain 0, but I will mention 2 here, and then the directory name. Now when you check
Why
the
are you
permission,
why are you mentioning there too, sir?
that is why, because it is GID.
Okay.
Now why I am saying 2, because you know this table. If this bit enable, you will get number 2, and that number 2 means SGID. If this bit get enable, the number will be 1, and then 1 means sticky bit, and next is what? This bit, and that bit means number 4, and that means what? SUID. That is what we are going to see next. So this is what a numerical way of assigning the SGID. When you check the permission of the directory, now you see here in the group owners permission, you will see S here. And whenever you see this S, that means on this directory, the SGID is enabled. And it is in group owners permission. And you can see the slight changes in color. You can see the change in color also. It is the normal, and this one is the change. Normal means when you give right permission to others, you will see like this, and this is what when you enable the SGID. Now what SGID, you see what in group owners permission, you see S. In place of execute permission, you see it is not showing read write X, it is showing read write S, and that means what? It is enabled SGID. Now if you check, and that means what? If you want to enable this in a symbolic way, that means you will use chmod, remember group plus S, because you saw in group owners permission it was showing what? S. So that means what? This is symbolic way. So that means if you want to enable the SGID as a symbolic way, so you will use what? G plus S. That means we are adding S in group owners permission, because you can see it is added into group owner permission, and it is added as a S, and in place of this execute. Now what it will do here, it will change the group ownership. Now when you see here, these files are already there, but these are not changed. These are still remain. The root is still the owner group, and user2 is still the owner user for this user2 file. Now when any user create file in that directory, now this is user1, it is in that directory, and it can see the file. Now this user creates a file, user1. Now if you check the permission, now you can see that user1 created the file, but the user1 is owner, is still the owner user, but the group owner is what? It is the owner of the group, that is sales. So file is created by user1, the user1 is still owner user, but the group owner is what? Sales. If user2 create a file, user2 is already created the file, it is already created one file, so it was previously created, so it is not changed. But now if the user2 create any file, u2, and now when you check the permission, now you can see this file is now created by user2. So user2 is still the owner, but group owner is now sales. If user3 create files, so you can see user3 is the owner user, but the group owner is what? Still sales. So whenever we do like this, whenever we enable the SGID, so the group owner of the directory will be group owner of all the files inside that directory. Whether the file or directory, whether whatever inside the directory, the group owner will always be the group owner of the directory. It is actually inheriting the permission. And the benefit is like whoever member of this group will get the read write permission automatically because of the default permission. So if I want to give a read write permission to a particular user on all the files inside this directory, I will make that user member of this sales group. So whoever create files inside this directory, always this group will be owner, and the owner group will always get the default read write permission. So the user I want, that user will also get automatically read write permission. Now to remove, or we can say to disable this SGID on directory, same like as sticky bit, we will mention 0 and the permission, whatever the permission we want. And this is what a numerical way. And for symbolic way, we will do -s. Remember, s, adding s in a group permission means enabling the SGID, and removing s from the group permission means disabling the SGID. So whether you run this 0 with the permission, remember I am saying permission, that means you can give any permission, you just have to mention this 0, or you can remove S permission from group owner's permission. So we can do this. So like this, we have already enabled. So it is already enabled. You can see the S here. Now I want to remove it. So simple, whether I use 077 on the directory or I can use G minus S. Both will work and both will do the same job. And you will see now it is removed. Now you will see no S. And that means we remove the SGID. One more thing, like a sticky bit, I will add this note also there. Now in this also you will see capital S and also small s, and that means also SGID. Like a sticky bit, it is also means what? SGID, and it also represents the same thing. It also represents the execute permission, and it will represent the execute permission for group owner. Group owner. And when we give group owner read write execute permission with SGID, then we will see what? Small s. And when we give group owners read write, only read write permission with SGID, then we will see what? Capital S. So this is same for sticky bit. That means if the group owner, because you see when we assign the permission, it shows the read write S here. It is not showing execute permission. That means we don't know that group owner is having execute permission or not. So it is represented by this small s. When you see small s, that means the group owner is having the execute permission, and when you see the capital S, that means group owner is not having execute permission. That means very simple, if I enable the SGID by doing this, like remember now I am using 6 for group owner. For sticky bit I use 6 for the others. Now I use 6, that means read write permission, no execute, I'm giving for group owner. And then you will see what? This capital S. And it means what? The execute permission is not there for group owner. And now I removed. Okay, so this is SGID. This is number 4. So number 1, decimal number 1, that means the first bit of 3, and that means a sticky bit. And then number 2, decimal number 2, that means the second bit of that 3 bits. and that means what? SGID. And now the decimal number 4, and that means the third bit of that 3 bits, and that means what? SUID. Now SUID means what? Now this means set UID. Now what is UID? We know that UID means user ID, and this comes with number 4. Now we know SUID means what? UID means what? User ID, and we have seen user ID means user's ID. Now set SUID means what? It is very simple, like SGID. This means what? It will set owner group. Now it will set user owner. It will set owner, user ID on file. Now remember, here I am saying file, I am not saying directory. Now because what, you can do it for the file directory also, but it is very good, it is useful when you use it on file. Now why we use it, and what it do actually? So file, that means it is actually not file, executable file. It is very good or useful on executable files. Now what is the executable files? Executable files can be a binary, or script. So it can be a binary file or a script file. So that means what? That means whenever that file will be executed, it will be executed by the owner user's ID. So it will executed by the owner user's ID, no matter who execute it. Now that means what? It is for the executable files, and what it means that whenever the file will be executed, it will be executed by the owner user's ID, no matter who executed. Now that means what? It is very simple. Now see, whenever you execute any script or binary, now binary means command, we can say it is a command. So whenever you execute the command, so our Linux system understands that this command or script is executed by the particular user. That means if it is executed by user 1, so our system will understand that this is run by user 1. Now how our system understand? Our system understand by the UID. It does not know the name, so it knows by the ID that this file or this script or this command is executed by this user, and this file is executed by this user. Now what that means if user 1 run any command, so all the permissions which that user has, it can do only that thing. That means it will get the privilege. That means it will get the privilege based on that user ID. So when it runs any command, so the privilege for the command will be decided by the user's ID. If it is user root ID, if the system sees that it is run by the root, that means it is getting full ID, full privilege. If it is run by any normal user, that means it will get the privilege according to that user ID. I will show you one example. So I'm showing you one example here. We have a command cat. Now this is what it's a command. If you can find this command, we know this which will find the command. So the command is under bin directory. You can see the path of the command is what? Bin directory, and it's a binary file. So if you check the permission of that command, usr bin cat. Now you can see the owner user is root, group owner is also root, and who has a permission here? So owner user is having all the permission, and other users and the group is also having only the permission of read and execute. That means all the users can do what? They can read and they can execute. Now they can read, because of that they can execute also. Other than that, if you give only execute, they cannot do anything. So they are having a permission of read execute, and for that reason all the users can run the file. That means if you see, this is user 1, so it can execute the file and it can do what? It can run and it can do the command. Now that means what? It is running now, and it is still running. It is not run and close. It is not like ls command, when you run it finishes the job and exit. It is still running. Now why I chose this one? Because it is still running and it keeps running, and we can check that who is running this. We can check that who is running this. Let me do this. I will execute it on this command line terminal. I will log in here as user 1. Now I will execute it here. Now if you see, this is user 1 and it is executing the cat command. It is doing what? It is just creating a file, and the command is still running. It is not closed, and that is why I choose this binary file. Now when you check who is running this, now I'm going to show you one command. Now this command we are going to see in detail, but for right now, for just testing purpose, I am showing you this command. This command is to check the process. That means whenever any system, whenever we have all the process, like whenever you start your system, you do your job, you run the process. So those processes run in background. We don't know that, but machine knows that by their process ID and who executed the process and what they have executed. So the cat command is already executed by user 1 and it is still running. So when I want to see that process here, so I can see here that this cat command is executed, and where it is executed, so it is executed on TTY2. TTY2, that means I goes into that F2 terminal, that is TTY2 terminal. Now who runs this command? If you can see here, our system knows that it is run by user 1. Now how our system knows? Our system knows because of the user ID. Because the user 1 run the command, so it gets the privilege of that user 1. And that means, and because what, and how it is getting the privilege of user 1? Because machine knows that it is run by the user 1 and it is run by the UID of user 1. So that machine knows that this is run by user 1 because it is executed by the UID of user 1. So whenever, and that means you can see here, I run this command right now on this terminal and it is run by root because I logged in as a root. So system knows that which command and which process is executed by which user based on their UIDs. Now I will mention you a scenario and why we do this. Now why we do this, we enable this SUID when for example, I'm giving an example, root when root create a script. Suppose root create a script. Now in the script means what? And script, and in the script root user add admins command. Now admins commands, or I can say admins commands. Now admins command can only executed by admin. That means whenever the commands will run, the machine will check the UID. Now if the UID is of root, then the command will execute, and if the UID of normal user, then the command will not execute. For example, I will show you one command also. For example, there is a command which is fdisk. Now you see this command is under sbin. Now sbin means what? It is super users binary, and it cannot be run by it will not run by normal user. Now if administrator run, if the root runs this command with this L option, it gets this output. You can see the output because it is executed by the root. So when root runs the command, system knows that it is executing by the root's UID, so it is having a privilege, so I am giving you the output, the command is working. Now the same command if run by normal user. Now this is normal user, user 1. If this user runs the command with this L option, what it gets? Nothing. Why it is not getting anything? Because it is not run by user root ID. It is run by user 1 ID. So it is not getting the output. So same as that, if administrator, if root creates an script and in that script it added the commands of admin, which is from sbin directory. Now if root runs the script, if root runs the script, it works. If root runs the script, it will work. Why it will work? Because it runs with root ID. But If normal user run it, normal user runs, it will not work because it runs by normal users ID. So when normal user runs, it will not run because the commands inside the scripts is belong to root user. Only root can execute those commands. Normal users cannot execute those commands. They will not work. Now there is a scenario when what the root user wants that script to be run by normal user. So now if root user wants to give that script to normal user for running or normal user to run. Now to run means suppose the root user is not there, always not there to run that script. It is most of the time working somewhere else. So he has some user and he has some junior administrator which is having a normal account, not a root account. Normally root account is not given to anybody. Root account will always be with the top administrator who is responsible for everything. All the second level, third level administrator will not get the root account, so they will get their own normal account. Now if there is a script which is run by only root and root don't have time to run that, so it will give what, it will create the script and give it to normal user to run. But whenever the normal user run, it won't work because the commands belongs to root's ID. Because of root account it will execute, otherwise it will not execute. So what root can do, what it can set, so it can do what root can set SUID on that script. And that means what, whenever that file will be, that means whenever that file will be executed, it will be executed by the owner user's ID and no matter who execute it. So whenever the script will execute, machine will understand, machine will feel that it is executed by root. Machine will not see that user ID. Machine will see directly the owner user's ID, and owner is what, root. Now this is not used normally because it is risky, because actually we can't track who runs it, because whenever it runs, it will run by the owner user ID, and if it is root or maybe any other user. So whenever you run that, it will run by the ID of that user, owner user. So if user 1 run, user 2 run, user 3 run, user 4 run, no matter who runs, it will always show that root runs this. So that means what, it can be a risky thing, that if it is because now we are not able to track that who executed actually, whether it is executed by one, user 2, user 3. So it can be a problem, but if it is a scenario, then we can do what, we can use it. Now for enabling it, it is very simple. chmod, we use chmod, and whatever the permission is, we will use what, 4, and whatever the permission, and then file name, Now remember, this is numerical way. So whatever the permission, you have to enable what? 4. Now to see this, to test this, I am going to do it on this file. I'm going to do it on this cat file. I'm going to do it on this cat file because you see, when we run the command with this user1, we saw that it was running and it was running by user1. We have seen it already, or I will show you again. So if I run it here and it is run by user1, and when we check the ps command to check who runs that, so we see here that the cat command is executed on tty2 and by user1. Now I will stop it. Okay, now I will enable SUID on this. Now if you can see, the permission, default permission is what? 755, but there is no SUID set. Now SUID means user owner ID, and that is what? Root. So you know that user owner is what? Root. So after setting the SUID, it will be executed by root no matter who runs it. If user1 run, user2 run, it always show what? That root run. It is run by root. So for setting it, very simple, chmod 4755 is the default permission. Under usr bin, this is the file. Now when you set this, it will show like this red color. That means it is corrupted. We should not do it on this binary file. These are default binary files. So it is showing red as a corrupted file. Now what it is showing here in the permission, you can see in the user owner permission, it is showing S. And that means what? If we want to do it symbolically, then we can do what? We can do it like this. That means user owner permission, I can do what? Add I can add what? Plus symbol. That means plus S in user owner permission, because you can see it is showing what? S in the user owner permission. Now you see what happens. Owner user is root. Now again I am going to execute it on this terminal by user1. Now previously we have seen it that it was showing user1 who executed it. Now I am again executing as user1, but now when I check the ps command, now it is showing here the command is executed on the terminal, that is the same terminal, but now it is showing executed by who? It is saying that executed by root. Now the command is actually executed, the binary file is executed by the user1, but still it is showing it is executed by root user, because the root user's UID is already set on it, no matter who runs it. Now if user2 runs it on this terminal, it is user2. Now it is run by user2 here. Now when I check again this ps command, now I see here that two cats are there. One cat is run on TTY2 and that is also run by root, that is actually run by user 1. Now again the cat is run and it is running on sudo terminal 2 and it is run by user 2, but it is still showing what? Root here. So whoever runs, it always show the owner ID, that is root. And that is the risk here, because you will not able to track that who actually executed it, because it always show that it is run by root user. Now if we want to remove it, I'm closing this. Now if we want to disable the ID, so for disabling it, very simple, what we do, we put 0 here, or we can simply put u minus s, and it will remove the SGID SUID from the file. So it will remove the SUID from the file. So for removing it, what we do, to disable SUID, what we do, same, for numerically we put 0, and for symbolically we put minus s. Now one more thing, this note, now this is again same for this also. That means sometime you will see capital S in place of small s, and it still means what? S UID, and it represents the presence of execute permission for user owner. And when we give other group user owner permission with SUID, then we'll see the small s, and when we give user owner read write permission with SUID, then we see capital S. So this capital and small, funda of this capital and small is same as for sticky bit, for group ID SGID, and for SUID. So this is same for all these permissions.